Hello students, welcome to the video number 8 in the video series tutorial about your intermediate kit course. So today we will be learning about the Adafruit IO platform and how to upload the data from our Vistry development board into it. So today we'll be using DHT-11 sensor in order to capture data about temperature and humidity, and we will be uploading it to the Adafruit IO cloud servers. So let's get started. Now once you visit the Adafruit IO website, you need to open your dashboard section. As you can see, I've already created my own dashboard, that is DHT-11 dashboard. Now you need to similarly create 3 different fields that we'll be using in order to show the data that is being uploaded. As you can see, I've already created 3 different fields, that is wise humi, wise read and wise temp, where we'll be storing humidity data in wise humi, the reading number in wise read, and the temperature data in wise temp. All we need to do is now create different blocks using the gauge type of block, where we'll be getting a humidity value anywhere between 0 and 100, that is the relative humidity in percentage. Go ahead and create the block. Similarly, we need to create the block that is the gauge for temperature and the reading number. For temperature also, we'll be getting a temperature anywhere in between 0 degree and 50 degrees Celsius. So better we give it a maximum value of 50. Now we need to create something to represent our reading number. However, we can't use a gauge because the reading number will go on increasing. So we are using a line chart in order to represent the reading number here. You can also create a stream that will show all the data coming in real time. Now all we need to do is go ahead and just align all our gauges and clusters in a very decent form that is appealing to our eyes. Just adjust them according to whatever you feel like, so that our data could be viewed very easily. Now all our data will be coming in these 3 feeds and will be shown on our dashboard. So now this is the code that we are using, which is based off the sample code that we have previously shown in the video. So let's go very briefly through what's happening in the entire code itself. 1 2 3 4 5 and 6, we are declaring several different libraries that we will be using. The first 3 libraries are for the Adafruit cloud servers, and then the library number 4 is for the getting the data. Now the library number 5 and 6 is for the DHT sensor that we are using in order to get the data of temperature and humidity. In line number 8, we are declaring the pin that will be receiving the data from the DHT sensor. In line number 9, we are declaring 3 floats, that is reading number, temperature and humidity. Float is like an integer, just think of it as a decimal point, so it can also store decimal values. In line number 12 and 13, we are declaring the Wi-Fi username and the Wi-Fi password. You can either create a hotspot from your smartphone or connect it to your existing Wi-Fi router. Now in line number 17, we are declaring the AIO server, that is io.adafruit.com, that will be fixed. Server port, that is 1883, that will also be remaining same. However, in line number 19 and 20, the username and key will be different in your case. Now we move ahead and come to the line number 25 and 30. These are the lines used by Adafruit library in order to communicate with the server. In the line number 35 to 37, we are making different datas that will be publishing to the Adafruit cloud services. For example, the value that will be stored in reading number, temperature and humidity will be published to these feeds to the right, that is feeds.wiseread, feeds.wisetemp and feeds.wisehumi respectively, as we have created in our Adafruit cloud. Then we have declared about what type of DHT sensor we are using. In this part, we are using DHT-11 in line number 39, and thus the line number 40 and 41 are commented out. Then we declare the milliseconds delay and the line number as the DHT pin types. Now we are using the line number 45, that is MQTT.connect, that is used to connect the microcontroller board to the cloud servers. So now our void setup begins. Here we declare the serial port, that is 115200 baud rate, and after a delay of 10 milliseconds for stability, we begin our DHT-11 sensor and we print Adafruit MQTT with DHT-11 by wise things. You can print whatever you like. We declare and initialize the sensors, and in line number 55 we try to print about the Wi-Fi details and when we are connecting to the Wi-Fi. We try to connect to the Wi-Fi in line number 59, and when the Wi-Fi is connected, we print Wi-Fi connected in line number 66 with IP address in line number 67. Now let's move ahead to the void loop part of the code. Here, as you can see, initially in line number 71 we have used the MQTT.connect that makes sure that our microcontroller boards is in connection with the servers from Adafruit and does not disconnect. Now we begin the sensors using the line number 74 and 75. Now in line number 76 we initialize the sensor and check if the data is coming. If the data is not coming, we'll print error reading temperature. Else, if the data is coming, we'll go and print the temperature at using the command event.temperature and also store it in the temp variable in line number 82. Now similarly for the DHT, we try to get the data in line number 86. If the data is not available, we print error reading humidity. Now if the humidity data is available, we go ahead and print the data using the serial port in line number 92 and also store the data in humi variable, which will be used later. Also we increment the reading number, that is every time we take a reading number will be incremented. Now we need to publish the data and tell the reading number. Line number 104, 105 and 106 are the lines used to publish the data to the cloud servers, that is the Adafruit cloud feeds. And in line number 107 we are using a 9-second delay in order to make sure that we do not overwhelm the Adafruit servers. I would recommend the delay to be anywhere around 5 seconds to 10 seconds from line number 110 starts, which makes sure that we are connected to our Adafruit servers and do not face any disconnection. Every time our code disconnects, we try to connect it again. Let's upload the code and start uploading the data from our Vistry development board to the Adafruit cloud servers. But before that, let us see how to connect the DHT-11 temperature and humidity sensor to our board. The VCC pin from our board, that is the top left pin, goes into the VIN pin, that is supplying 5 volts. The middle pin, that is the output data pin, goes to the pin number 5 of our Vistry development board, and the pin on the right, that is the ground pin, goes into the ground terminal as shown by this wire. The VCC here is purple, the orange wire is the data wire, and the brown wire is the ground wire. As you can see on our serial port that our Wi-Fi is connected and also the MQTT is connected. If your Wi-Fi connects and MQTT fails to connect, recheck your AIO server port and the generated key. Now as you can see, we are publishing the data onto our AIO servers. Let's go and check out our readings. As you can see, the time and details that match onto the receiving end and on the sending end. That means we are in real time publishing all the data onto the server using the Wi-Fi and internet. This can also work as a standalone device. That means you can easily just hook up that battery pack onto those terminals and use it as a standalone device in order to measure and monitor the temperature and humidity of your room or anywhere you like to place it. We can also see our data coming live in the live data section of the monitor. If something is wrong with some of your feeds or dashboards, you can still view the live data in this monitoring section. You just need to make sure that the feed you are uploading the data to and the feed you have created is matching in their names. So this is it for the video number 8 series tutorial of Adafruit MQTT cloud servers. So hope you like this video. We'll meet next time with another video. Thank you guys for watching.